Welcome to Spaceflight Questions and Answers, Edition 4.1, where I answer the questions you have asked. NASA seems to have no plans beyond a few one-off or few-off landings for Artemis. What about outposts, bases, infrastructure, power, Earth, etc.? What is your expectation for NASA versus or in partnership with private development? NASA has a document called the Artemis Plan that has some details for what they call the Artemis Base Camp. It has a bitchin' lunar side-by-side rover, a foundational service habitat, and, well, not much else. The habitat might show up in 2033 if one thinks the current Artemis schedule is credible. You'll need a lander to carry those to the surface, and since Orion can't put heavy loads into near rectilinear halo orbit and then get home, it will need to come from Earth on the lander as well, which means getting it there is likely a purely commercial mission. Even with that, I don't think NASA has the extra bucks to support a lunar base, even with current budgets. Do you think the point-to-point cargo transfer that the US military will do with Starship will require a booster, or will it be a modified upper stage? Interesting question. To that point, I'll make two observations. The first is that Starship is a vehicle that is as close to a single stage to orbit as is practical. Super Heavy only adds a minor amount of delta V, aka oomph, as that minimizes the penalty of landing it back at the launch site. The second is that while getting into orbit takes about 9,400 meters per second of delta V, getting halfway around the world on a suborbital trajectory only takes about 7,900 meters per second of delta V. If you're willing to accept a reduced payload, my guess is that you can do it with just Starship, and if you want a lot of payload, you might want the whole stack. Does the Blue Moon lander even exist? Blue Origin doesn't talk much, so we don't know where they are in the development process. We do know that in contracts like these, there are incremental payouts as the company achieves specific milestones, and those are public knowledge. We don't know the actual amounts, and I couldn't find much detail about the milestones in the Blue Moon contract. The current information says that Blue Origin has received $684 million out of a $2,900 million contract, and that means they are 25% of the way through, at least from a money perspective, which honestly doesn't tell us much. I should probably note that SpaceX has received pretty much all of the money for their first HLS Starship contract. It makes sense for both SpaceX and Blue Origin to front-load the money that they get paid for these contracts. My guess is that most of the 25% that Blue Origin has been awarded is for design studies and reviews that NASA requires, and that means they're likely working on hardware, but we have no idea how far along they are. And that's basically the same with the HLS Starship. What's your assessment of the commercial LEO destinations program? Which stations do you think NASA will choose, and/or do you think it's likely we'll have a commercial space station in orbit before ISS needs to be deorbited? Here's a video for you. I don't think Congress cares about funding this and ISS at the same time, if at all. And I haven't seen anything since I did the video that would encourage me to think there will be an agreement between NASA and the possible suppliers. NASA and Congress want something that will be cheaper than ISS, and I don't think there's a business model that makes the other stations practical. I do think that there's a decent chance that Axiom will get their first module up to the ISS before it's time to deorbit, and they will somehow inherit all of the really expensive equipment NASA wants to keep in orbit. But it's not clear what their business model is either. And here we have a news flash. Since I wrote that answer, NASA has altered their commercial space station strategy to use the approach that they use for commercial cargo and crew. Instead of a pure, firm fixed price approach, they will use Space Act agreements to pay companies to develop commercial space stations. There will be a separate certification program before NASA will buy space on the station. They have also reduced the occupational capacity from full to 4 crew for 1 month increments. I think this approach is likely to work better, but it's still not clear what Congress will think about this change. Is there any reasonable future technology that could take ice or water to low Earth orbit cheaper than Starship? From the Earth, no. We use chemical rockets because they work, and none of the speculative approaches look promising at this point. From elsewhere, you could do it from the moon, and there are a couple of possibilities for getting water from asteroids, but neither are near term. Given your recent video on Starship's problems, what are the likely impacts on SpaceX, Artemis, and the wider launch industry if the program fails or is significantly delayed or scaled back? I don't know. Here's a short list of factors. How Blue Origin does on Blue Moon. What Starship ends up looking like. Who is the president and how much they care about the moon. How the SLS Congress people respond. Who is in control of Congress? Who is in charge of NASA? What China is doing? Etc. Give me 5 more minutes and I'll double that list. Too many factors, too many people, too many unknowns. Remember that 6 months ago it looked like SLS might be cancelled after Artemis 3. But right now it looks like the SLS Congress people are going to prevent that. Or at least try. Do you have enough information to do an analysis on JP Aerospace? And would you consider doing a video on them in the future? There's not really anything I can comment on. As far as I can tell, there are just a few renderings with few details. With the airship to orbit, you somehow need to get this very large and high-drag vehicle up to orbital velocity without losing all of your energy to drag. Seems really hard to do. Do you know what experiments NASA is going to do on and around the moon? NASA, of course, has a document that explains this, the implementation plan for a NASA integrated lunar science strategy in the Artemis era, dated November 2024. They list 6 big challenges. The first 3 are South Pole, Aitken Basin sample return, Lunar Geophysical Network, Cryogenic Volatile sample return. The second 3 are a bit more diffuse. Lunar chronology, lunar formation and evolution, and lunar volatiles. You did a lot of radiator explanations recently. Moon to Earth round-trip latency is some 2.5 seconds. How about data centers on the moon? Polar regions have permanently illuminated spots for solar. How hard would it be to use regolith as heat sink? It's possible. The problems are, you need to get down to the regolith and transfer heat effectively. Deployment is more difficult, and you might run into issues at specific sites. We have essentially 0 experience at what we might find when we try to dig deep holes in the moon. You likely need a pumped fluid system, and radiators work and just keep on working. Radiators are just easier for early systems, and they're probably lighter and cheaper, and you can move them around. Or perhaps we could just do what the Innovation New Network says the Chinese are going to do. Do you think it is possible for a private enterprise to get moon rocks or moon dust and sell it for money as a way to finance space technology development, or just to make a profit? There seems to be a market demand for moon rocks. It's really hard to get to the moon and back. My guess is that you only get 500 kilograms or so of lunar rocks back if you launch your very expensive lunar return mission on a Falcon Heavy. $200 million is a decent estimate for the cost of that, which means your cost is $400,000 per kilogram, and your price is probably double that. Doesn't seem there's likely to be much market there, at least right now. Suppose you got a few billions of dollars to start a space company. What would be better, bigger rocket for larger payloads, or smaller rocket for higher cadence? Launch companies are mostly a sucker bet. Rocket Lab and Stoke have a decent chance to offer some competition with SpaceX, and there's no reason to think that anybody else will do as well as they do. Could Starship make a capsule that pops out of the fairing for humans if the flip maneuver is deemed unsafe for humans? It's possible, but presumably that capsule would use parachutes and they aren't terribly reliable. Here's a video with more information. What are the chances humans walk on a near-Earth asteroid before Mars? Seems like an easier mission to test some of the Mars capabilities. Not many people know that when SLS was first proposed, the mission that President Obama wanted to do was a crewed mission to a near-Earth asteroid. Then it smartly got changed into a mission to bring an asteroid back to lunar orbit where it could be visited by astronauts. This was required because there's no way that SLS or Orion could get to an asteroid and return. There's a neat site called Asterank that lets you browse for different asteroids. There are a few that require less than 4,000 meters per second of delta V, but getting to the surface of Mars only requires 3,600 meters per second of delta V if you aerobrake on the way down. I can confidently tell you that humans will never walk on a near-Earth asteroid, because even on the biggest near-Earth asteroids, gravity is only 1/1000th of a g. If you were a 100-kilogram human, you would weigh only 140 grams, not something you can walk on. Do you see pellet beam propulsion ever being a viable means of transporting cargo? Pellet beams, also known as mass beams, use a small spacecraft with a reflector that you shoot things at. It's a bit like the Orion nuclear bomb spacecraft, with pellets instead of bombs. You generate the pellets at Earth and fire them at the spacecraft. Then the spacecraft has some way of vaporizing the pellets into plasma, which then hits the back of the spacecraft and accelerates it. The advantage is that the spacecraft has no fuel to carry. The disadvantages are many, and I don't think it's a practical design. Do we have any hard evidence proving that Falcon 9 has significantly reduced launch costs? This question referenced a YouTube video that I haven't seen, mostly because writing videos is a better use of my time than watching them, and I don't do response videos. There are really two questions lurking here. The first is whether Falcon 9 has significantly reduced the price to launch payloads. The second is whether Falcon 9 has significantly reduced the cost of launching payloads. For launch price, I think the question is going to revolve around what you think is a significant reduction in price. Falcon 9 has been roughly a $65 million rocket for commercial launches. Price is a very squishy thing in commercial launch as the exact prices are rarely disclosed, so these are estimates. Its two main competitors were the Russian Proton, which was also roughly a $65 million rocket, and Ariane 5, which typically launched two satellites, a lower berth for a smaller satellite at around $70 million, and an upper berth for about $105 million. Initially, Falcon 9 was a bit cheaper than Proton's $65 million, and it killed Proton because it was cheaper, and insurance on Proton was more costly because of its horrible safety record. Easier scheduling was also a factor. SpaceX undercut both of those prices and was able to attract business away from Ariane 5. I would say that Falcon 9 was significantly cheaper than Ariane 5, and that led Ariane to reduce their prices. Remember that SpaceX's goal was to create a successful business, and I think they priced Falcon 9 effectively to do that. The second market is launches for NASA. For many years, ULA had enjoyed a monopoly on NASA launches. NASA paid ULA $307 million to launch the Perseverance rover on an Atlas V. There's no direct comparable launch, but we do know that Falcon 9 has launched NASA payloads for $100 million, sometimes less. Since SpaceX was certified for NASA payloads, they've won the vast majority of the contracts. For initial cargo resupply to ISS, Dragon cost about $80,000 per kilogram delivered, while Cygnus cost about $135,000 per kilogram. Dragon can return materials from ISS, while Cygnus is a one-way trip. The current cargo Dragon pricing is closer to that of Cygnus as SpaceX realized they were leaving money on the table. Cargo resupply has been cheaper than shuttle resupply, but not by an order of magnitude. Overall, I would say that the price for NASA payloads has been reduced significantly, especially on NASA science missions. The final market is national security space launch. Falcon 9 launches were about $100 million per launch, and Atlas V was in the range of $150 million per launch, and the Delta IV Heavy was over $400 million per launch. That is not a misprint, and before SpaceX came along, ULA was getting launch capability payments where they would get paid approximately $1 billion per year to be ready to launch government payloads, even if no payloads were launched. The existence of Falcon 9 led to the creation of Vulcan, and in the current bids, Falcon 9 and Vulcan are roughly equal in price, with ULA working hard to make Vulcan cheaper and SpaceX no longer needing to underprice their launches. The DoD is ecstatic about Falcon 9. It has saved them tens of billions of dollars in launch cost. Overall, Falcon 9 has had an impact to lower prices, but it's important to remember that there has been no competitors that have been underpricing what SpaceX charges, and therefore they have no incentive to reduce the price of their launches, and every incentive to increase their prices to be close to what they expect their competitors will bid. Now let's look at cost. This is another squishy thing, because you need to not only consider the per-launch incremental cost, but the fixed costs that are spread across all the launches in a year, and launch companies have large fixed costs. Falcon 9's first commercial launch was Cassiope, and they charged $61 million, so it's a fair bet that their cost was less than that, because they needed launches to generate enough cash flow to allow them to pay for their fixed costs and do additional development work. They were clearly keeping their price low to attract customers who weren't sure about flying with them, but given that their US competition was Atlas V, they likely could have priced higher if they wanted to. They flew 9 commercial payloads before they were able to land the first booster. There was clearly demand, but they kept their price at about $60 million. That's another indication that their incremental cost was lower than their cost. But I think the real question is about reuse and its effect on cost. The first observation is that there is no logical reason for SpaceX to go to the trouble of landing boosters and recovering fairings and bring them back to be refurbished and flown again if it doesn't save money. And once SpaceX expended all of the Block 4 boosters, they have been continually landing and reflying boosters. The second observation is that there is no reason to suspect that SpaceX is spending a ton of money on refurbishment. If you look at the size of their infrastructure at Kennedy Space Center, it's just not big enough to support extensive refurbishment. And that was back before they started flying Starlink, when they were flying 20-ish times per year. They're now flying over 120 times a year. That means they have higher utilization of their barges and ships, which makes them cheaper. They've gone to much higher production of Falcon 9 second stages, which makes them cheaper, and they are spreading their fixed costs across 120 launches rather than 25. There's no world in which the cost of a Falcon 9 launch today isn't much cheaper than the early Falcon 9 launches. Are you still holding on to Rocket Lab stock, and how long will you hold? Yes, I'm generally a follower of Warren Buffett, who said, "The best time to sell a stock is never." But the real answer is that I hold on to stocks until I think the reasons that I bought the stock no longer apply. And my Rocket Lab holding is what I call amusement scale. It's not enough money to result in much change in my finances, whatever happens. In your last video, one of the challenges was radiator size. How much mass would those radiators take up? And how much of an issue is thermal management in human spaceflight? You can look at one of the studies I linked to in the video description for more details. ISS needs decent-sized radiators, and shuttles needed to use their payload door radiators to stay cool. In Orion, the outer wall of the service module consists of 6 curved radiator segments. You said that the Falcon team would be very ashamed if they were in the place that Starship is right now. But don't you think the problem lies more in management than the capabilities of the team? Because I think the Starship team is just as, if not more capable than the Falcon 9 team. I actually said embarrassed rather than ashamed. Capability is measured by demonstrated track record. The Starship team looked pretty good through the hop tests and okay in Block 1. But until Flight 10, they hadn't demonstrated progress in Block 2. This isn't to say that there aren't very talented people on the team, merely that they weren't making forward progress, and that's the only way to measure capability. SpaceX has a quite ambitious launch cadence goal for Starship. If they can do it, do you see Starship launches being limited by demand? What kinds of payloads could consistently sustain weekly or even daily launches on bigger and bigger Starships? With the exception of Starlink and Mars missions, Starship is a solution looking for a problem, and that's unprecedented in the launch and satellite industry. It's not clear to me what companies will make of that capacity. Space mission planning and modeling tools? Look at NASA's Space Mission Design Tools page. GMAT looks like a great place to start, and you can find it on SourceForge. What should Europe do in order to catch up with the US space launch industry? The European Launcher Challenge is a decent start, where ESA has said they will buy flights on these new launchers. Unfortunately, the development isn't funded by ESA. It needs to be funded by the nation where the company is located, which means they aren't really European launchers. They're member country launchers. They presumably did this to avoid the long discussions that ESA has whenever they try to do anything, because each country wants to get something back for the money they're putting into it. But it seems fairly likely that there will be some countries who win and others who lose, and that is likely to strain the ESA relationships. How much advantage does the extensive public coverage and analysis of Starbase give adversaries like China? What could be done about that without diminishing the positive effect it has on STEM promotion? Most of your questions are answered in this video. Why do ion engines use xenon or argon as a propellant, but not helium? Considering that helium has a much smaller molar mass, it should have a higher ISP. This is a fun one because the answer is counterintuitive. As specific impulse goes up, thrust goes down. And for ion thrusters, the thrust is already very small. You're correct that helium would give a much higher specific impulse, roughly 6 times the specific impulse you would get with xenon. That means that your engine is much more fuel efficient, but your thrust would be 1/6 the amount. And you need much larger tanks because the density of xenon is 33 times the density of helium. You have a hyper-efficient thruster that uses almost no fuel. But a heavier spacecraft that takes forever to get anywhere. If you want the math, there's a link to a Reddit post in the video description. Would the Venture Star have worked as intended? No. This is a video on spaceplanes that explains why. Note that while there are companies that are happy to take other people's money to develop spaceplanes, nobody is lining up to spend their own money. What do you think of solar sails powered by lasers, whether ground-based or with the lasers on the ship? I think the problems are power density. Rocket engines produce really high power levels, and high-power lasers aren't cheap and powerful enough. And loss of power as you get farther away due to the inverse square law. There are some designs that would probably work, but they involve very small spacecraft and 100 megawatt laser arrays. See Breakthrough Starship for one such concept. Here's another one. Does laser propulsion hold any promise? I think the power density requirements are really, really high. The calculations I've seen suggest that a Falcon 9 is putting out about 26 gigawatts of power. The most powerful continuous laser seems to be the one Lockheed Martin is building, and it's a 500 kilowatt laser, though that may be the input power rather than the beam power. Which industries will be the first to have a real production in space? How is the timeline? And who's working towards it currently other than Varda? That's a question NASA has tried to answer for decades on the ISS, and it isn't clear if there is actually a market there, at least at current launch costs. Varda is starting as small as practical to discover what market there is, and so far, it seems to be working. It feels like Earth observation and satellite internet are the biggest commercial space business models right now, but what do you think will be the next big near-term businesses? Here's 3 videos for you. The short answer is that Earth observation and communications are the proven markets. Launch right now is probably still too expensive for manufacturing. What if second stage reusability remains hard for the next couple decades? Like, maybe not impossible, but still either risky, refurb heavy, or not human safe. If second stage doesn't work, then we're stuck with first stage reuse, and companies will optimize for that. The AR-1 rocket engine is on a development pause, or development crawled to a halt with the move away from Kerolox. However, licensing cost aside, would a Kerolox engine like the AR-1, once it's developed, not be more practical than a Methalox engine? Here's 2 videos for you to watch. Methane is better from a reusability standpoint and likely cheaper in cost, though propellant costs don't matter much until you get to full reuse. It is interesting to note that ULA decided to go with the unproven Blue Origin engine development team rather than the Aerojet Rocketdyne team, though the last high-performance engine that Aerojet Rocketdyne built was the RS-25 for the Space Shuttle in the 1970s. And that's all the answers for episode 4.1. Thanks to everybody who asked questions. If you've gotten this far, you might want to take a trip to eagerspace.net, where you can find all the past videos and the scripts for most of them. If you enjoyed this video, listen to this.